Hi everyone. Today I'm going to discuss factoring difference of two squares. So before working on factoring, let us consider how this factoring will work. So we have to consider the terms that are being used here, like difference. So we are actually factoring difference. So difference implies subtraction operation. And then two, we are referring to two terms. Squares are perfect square expressions. So the left side describe the polynomial that we are trying to factor. So this is the difference here of the two terms, which are both perfect square expressions. And before we work on the factors, let us recall and answer each of these questions. And this will help us come up with a perfect or a complete factor for each polynomial that we are trying to factor. So what are perfect square expressions? So basically, perfect square expressions are expressions when raised to the second power. Now, if, for example, we're going to consider raising all these expressions to the second power, the result will definitely perfect square expressions. So 1, 4, 9, 16, and 25 are perfect square expressions. As regards to algebraic expressions like m to the 100, n to the 20th, j to the 10th, k to the 40th. So these are also perfect square expressions. By inspection, look at the exponent. So each exponent of each expression is even. So that's how we describe a perfect square expression. Now, the next question is, how do you extract the square root of a perfect square expression? So basically, we just divide the exponent by 2. So if we extract the square root of m to the 100, this is m to the 50th. N to the 20th, this is n to the 10th. J to the 10th, I mean, the square root is j to the 5th, and then square root of k to the 40th is k to the 20th. Now, the square root of these expressions are actually the base of the right side of the equation. Now, why do we need to answer these questions? So this will help us work on a complete factor of each polynomial that we're trying to factor using this pattern. So the factors are the right side of the equation. How did we come up to these factors? So this is actually the product on the sum and difference of the same two terms. If you remember our discussion on special products, and the product is actually the difference of two squares. Now, as what I was saying, we are working backwards as we consider factors of the right side here. And the factors are actually the square root of both terms here. So that's why we need to consider how do we extract the square root. So square root of x squared is x, while square root of y squared is y. Now, x and y here will be the terms of the factors, like we have xy, xy here. If one is addition, the other one is subtraction, or vice versa. So we can rewrite these factors into considering x minus y as the first factor and x plus y as the second factor. So these are the same. So remember that the order of factors or multiplication does not matter. So whether you consider this as your first factor or this as your second factor, it doesn't matter. Now take note that one must be subtraction, the other one is addition. So it should not be both subtraction nor both addition. So let's try working on the factors of each binomial here. So we have to consider the difference of two squares, and the difference of two squares equal to the product on the sum and difference of the same two terms. So we have x plus y, x minus y here. So this will be our pattern. Now, by inspection, definitely the first example both terms are not perfect square expression. So we have to consider moving out its common factor, or should I say greatest common factor. So if we do so, the greatest common factor will be 5x. And from the previous discussion, working on the GCF as one of the factors, we'll come up with the other factor by dividing this expression by the GCF. So when we divide 20x y squared by 5x, we'll have 4x squared. And then negative 5x divided by 5x is negative 1. Now, take note that the second factor is still factorable, and this is actually the difference of two squares. So both terms here now are perfect squares, and the operation is subtraction. So we can work on this pattern. So we just have to work on the square root of 4x squared, which is 2x, as well as the square root of 1, which is 1. And this will serve as factors, but do not forget to write the GCF as the factors. And then we'll come up with two binomial factors, exactly the square root of both terms here. So we have 2x and then 1, 2x, 1. One is addition, the other one is subtraction. So these are the factors. Now, both terms here are perfect square expressions. So we have to work on the square root of 81m to the fourth, and then square root of n to the fourth. We know that the square root of 81m to the fourth is 9m squared, while the square root of n to the fourth is n squared. So we have here 9m squared plus 1, and then 9m squared minus 1. These are the factors, but try to look at the second factor, and it's still factorable. In fact, both terms here are perfect square expressions, and the operation is subtraction, so we can work factoring the second factor by considering the difference of two squares. So we have to factor this out, and the square root of 9m squared is 3m. 3m here. Square root of 1 is 1. So plus 1 minus 1. So the complete factors for number 2 are three binomial factors, namely 9m squared plus 1. And then we have to write the two factors here as factor of the second factor here. So we have 3m plus 1, 3m minus 1. Now, may I remind you that these are the factors, but these are not the complete factors. So when I say complete factors, each factor that you have presented is no longer factorable. But in the case here, 9m squared minus 1 is still factorable. So these are the complete factors. Instead, these are the complete factors. For number 3, both are perfect square expressions. We just have to work on the square root of both terms. So square root of 49a squared is 7a, while square root of 4b squared is 2b. So we have to rewrite this here. And then one is addition, the other one is subtraction. So that's the factors. Here, again, both terms are perfect square expression. So square root of 121h squared is 11h. And then let's put it here also. And then square root of 4 is 2. One is addition, the other one is subtraction. Likewise here, both terms here are perfect square expressions. So we just have to extract the square root of 36r squared. So that's 6r. And then 6r also here. Square root of 1 is 1. Square root of 1 is 1. This is addition. This must be subtraction. So here, 8x to the fourth minus 8. Obviously, both terms are not perfect square. So same with what we did in the first example. We have to divide both terms by its GCF, and we have 8 here. So as we divide both terms by 8, we have x to the fourth minus 1. And the second factor is factorable. In fact, both terms are perfect square. So the factors are the square root of both terms. So this is x squared. This one is x squared. Square root of 1 is 1. But then again, this is still factorable and both terms here are perfect square. So the factors are square root of x squared and then square root of 1. So the complete factors are 8, x squared plus 1. And then the factor for x squared minus 1 are the two factors here. So these are the complete factors. So working on the factors as regards to the difference of two squares is very easy. You just have to find out if both terms are perfect squares. If not, maybe you can factor out both terms by their corresponding GCF. Now, if the result after you divide the expression by its GCF turned out to be the difference of two squares, so that's the time that you have to work on the factors. So you just have to extract the square root of both terms and then consider the extracted square root as the two terms and then separate the two terms by the addition and subtraction operation. So basically, the factors on the difference of two perfect squares equals on the product on the sum and difference of the same two terms. Before I end my discussion, I'd like you to work on this example. So I want you to factor completely each of these binomials and write your complete factors in the comment box section of this lecture video. So I hope you're able to understand what I have discussed and see you on my next discussion. Bye for now.